So one of the examples I give you in the book and in the lecture is creating a blueprint class for a die. So die is singular for dice. This is actually one of my favorite programs to do because it's simple and it's something that we can visualize. So here I drew a die object. Now a die has 6 possible values, and those values range from 1 to 6. When we write a blueprint class, it's important to think, how does that object actually behave? What are the values that we're tracking? So really the only value for a die is its face value. A die is pretty simple. It only has data for a face value, but the behaviors of a die can be a little complex. So what are some of the behaviors that we have with a die? What are the ways that we interact with it? So typically whenever we have instance data, we always make a getter and a setter for that instance data. The getter would be if we were to look at the face value of our die object and note what the face value is. So when we look at our die, we're simply getting its value. So I'm going to add that as one of the methods we need to create. And the other thing that we can do is set our face value. So setting the face value would be if we were to pick up this die and just set a different face value facing up. So we would be able to change the face value from 2 to 1 simply by picking it up and setting the 1 value facing up. So another way that we interact with the die is if we were to pick it up and to roll it. When we pick it up and roll it, instead of setting it to a specific face value, we're actually randomizing what the result is. So we can grab this die and roll it and get a random result. So our die object actually seems pretty simple. We get its face value, we can set its face value, and we can roll the die object. Now the other method we need to keep in mind is we're going to have to override our toString method. Overriding the toString method is something I'm going to require you to do for all the classes that you turn into me, whether it's on quiz, homework, or an exam. So the last thing I want to note is we are going to have to keep this face value between 1 and 6. So keep this in mind. There's some things that we can do in our setter to force this behavior. We're also going to have to do the same thing in our roll method. So let's go ahead and design this class. So I created this class so that we can design the blueprint for our die object. So the first thing I need is instance data for my face value. Another thing I want to do is create constants for the min and the max value of my die. Now that I have my constants for my min and my max value of my die, I want to go ahead and make the getter and setter for face value. So here is a getter and a setter for my face value. But one of the things I want to do in my setter is prevent my face value from being set to any value outside of the range of my min and max. So I'm going to go ahead and add an if condition. Now you don't have to do this. We won't learn about this until chapter 5. I'm going to go ahead and do it because it makes more sense if I do. So now that I have my getter and my setter, I want to go ahead and create my roll method. Now in order to randomize my face value, I can use the random class or I can use the math class because the math class has the random method. I'm going to use the math.random method to randomize my face value. So here's my roll method. I made some comments here so that it's easier to understand what I did here. Whenever I use math.random, I get a range of 0.0 to 1, not including 1, but I'm multiplying that to my max. My max is 6, so then I'm getting a range of 0.0 to 5.99999. Now when I cast that to an integer, that's going to force that range to be 0 through 5, and then I'm adding my min to it, which is my 1, and now the range would be 1 through 6. So this is how I'm randomly generating the face value. So the next thing I want to do is create my toString method. Here's my toString method. I'm simply just printing out a string that is going to give me my face value. And that's really all I care about, is just to know what the face value of the die is. I'm going to go ahead and make a driver class to test my die blueprint class. I want to name that class dice game. So I created this program to test my die blueprint class. I instantiate 2 die objects and then I print out the results. Now printing these 2 objects to the console is going to invoke my toString method. So I'm going to go ahead and compile and run. So I compile and run, and this is the result for die 1 and die 2. Now you can see that my face value is 0. So having 0 as a face value makes absolutely no sense. So what I need to do to correct this problem is add a constructor, and within that constructor I'll set the face value to a value within the range of 1 through 6. So here's my constructor. Within my constructor I'm setting my face value to min. Min is 1. Now it's important to note that the name of your constructor always matches the name of your class, and the name of your class always matches the name of your file. So now that I added a constructor that sets the face value to something that makes sense when I first instantiate my object, I'm going to go ahead and compile and run this program. And here's my result. So now what I want to do is update this program to test all the methods of my die blueprint class. My die blueprint class has a getter, a setter, a toString method, and a roll method. I want to make sure I test all of those and verify that I get the correct results. So the whole purpose of this driver class is to test my die blueprint class. So I went ahead and tested all the methods in my blueprint class. The first thing I did is printed out the initial value after I call my constructor. So I want to verify that this is 1, because if you look back at my constructor, I set the face value to 1. Then the next thing I do is verify that I set the face value within range. So I'm passing in values that are within range. Then I'm calling my get face value to verify those results. So I'm testing the set face value and the get face value. Then what I do is try to set the face value outside of the range. Now I did add in those if statements to prevent this from happening. So the whole purpose of this is just to verify that I can't set my die value outside of the range. Then I roll my dice 3 times each. So I roll die 1 and 2. I print out the results, and then I print out what the sum is of the two, by summing the face values. So I do that 3 times. And then the next thing I do is verify that my Tostring method is working by simply passing the object to the system out print line. So I'm going to go ahead and compile and run this program. And here are my results. This is the value after I constructed my object, and then I set the face value within range. The next thing I did was try to set it out of range, and you can see that those values didn't take. Then I rolled my dice 3 times and I print out the sum. So I got 4 for both. Then I got a 2 and a 3 and a 2 and a 4. And there's my sum. And the last thing I did was verify that my Tostring method is working. So the die blueprint class was actually pretty simple once I examined what I needed to do. I drew up how I interacted with the die object, and I was able to come up with the methods that I needed. Now remember, every time you have instance data, you're always going to have a getter and a setter. Is do something similar to this, but write a blueprint class for a coin that you flip. So if you go on a canvas, you should see a quiz for coin. The coin is going to work just like the die class. You're going to have a face value, except the face value is going to be 0 through 1. Now this is a coin just for the purposes of flipping. So there's no value associated with this, so you don't have to worry like if it's a quarter or nickel or dime. The only thing we're going to track is face value. You're going to have a get face value, set face value, but instead of having a roll like we did for the die, we're going to have a flip. You're still going to have a Tostring method, and the coin is going to work similar to the die, but it's only going to have 2 sides. It's going to have a heads or a tails. The way you get the face value is just by looking at it. The way you set the face value would be if you pick up the coin and set it to a heads or a tails, and when you flip, you're actually just getting the coin, flipping it into the air, and you're getting a randomized value of heads or tails. Now instead of returning heads or tails from the face value, I want you to just use 0 and 1 to represent heads and tails. So we can say that 0 is going to be our heads and 1 is going to be our tails. This should be fairly simple considering that we just did it for a die and had 6 possible values for a face value. Whenever you design a blueprint class, it's always good to think about what instance data you need and what methods you need. But it's also good to think about what constants you're going to need. So for the coin, let's think about what constants we're going to need. So obviously we're going to need constants for the heads and for the tails value. So we can go ahead and note that. And you're also going to need the number of sides of a coin. There's 2 sides to a coin. And you're going to need that in the equation to flip because you're supposed to use constants instead of literal values in equations. So you should have a 2 somewhere in your equation. If you find a way to do it without using a 2, then you don't really need the number of sides. But in most cases, you will need a constant for the number of sides. So these are the constants that you should have for this coin. These 2 for sure you need. This one maybe not so much if you can think of a way of not using a 2. It all depends on how you generate your random number.